Welcome to this September monthly meeting. The image you see on the screen, this title is Trina Johnson's contribution. A newly minted astrophotographer. Yeah. She says no, but I think she's drifting. That image from the blog at LLCC. So here are the members of the board. I am the president, Mark Jobe. I know John Zimmich is not with us tonight. I know Conrad Sanders is off the continent. He's in Portugal. And Trina is in the room tonight, and Matt, the treasurer, is in the room tonight. And I don't know if Gunner's online, but he usually is. If he isn't, he will watch us later. So there are our mugs. Somebody needs to shave. Here are the newest members. Welcome, new members. And I was around the room, and I talked to 4 different people about new members. Is there anybody else? Anybody I miss? Cool, good. And I know there's probably several online. Welcome new members. You know, I think I say this every month. The greatest astronomy club. Well, maybe everybody says the universe. Yeah, so it's unanimous in the room. The universe. I mean, we have so much to offer. There's so many different things to do. There's so many ways to become active and be involved in the running of the club. Organizing things, volunteering, outreach, just peer sharing, showing up at a star party. You know, and then there's all the things that everybody does on their own. You know, that, you know, if somebody says, if you're connected with any group or anything, well, you know, now you are. And, you know, I really urge you to get involved in the club because it is what you make. And, you know, I've been a member of the club for, I don't know, Steve would know and I could ask him and he could look it up and he'd say like, yeah, I've been between 10 and 12 years. And I mean, I think I've been fairly active. I've been involved in the board early on and committees specific for Eagle Lake Observatory. I key holder for a couple different observatories. I mean, that's just me. I mean, everybody in this room they're involved somewhere. And I think that's you have to do that. Otherwise, you know, I don't know that you get anything out of it. And I think we have so much to offer, you know. I guess I shouldn't leave out the Astronomical League and the observing awards and all of that. You know, there's those opportunities too. And we'll get to some of that yet tonight too. And trust me, if you have a question, you can ask anybody that's a member, that's been a member for any amount of time, and you're gonna get a response. And if you don't get a response, they're most likely going to point to go talk to that person, you know, or go talk to Dave. Dave's in the room, so exactly. That's even better. Right, moving on. How'd that happen? Oh, sorry, Vaults. So I like to thank volunteers every month, people that have stood out in my mind. Vaults D. Thanks, Vaults D. All the work you've done on the website, the work that you're currently doing on rolling over the forum to get that secure and safe and just easier to maintain. I know Clayton's been involved in that, and I know LLCC committee worked really hard and put on quite a show up there in NNSF. That was a blast. That was tremendous. So I personally would thank them. And there's other volunteers. I don't just want to point out just these people. You know, there's star parties that happen at ELO. There's work parties that happen at ELO. I mean, people pulled weeds out at Joseph J. Casby. You know, those maybe they should be up here. You know, because pulling weeds, that's, you know, that's not fun work, but it's work that we have to do as members. I mean, we all contribute a little bit because if they don't get pulled, pretty soon they're up to our waist. And, you know, then our host, who is the Bellwind Conservancy, asks us, you know, when are we going to take care of the weeds? And we don't want that. So we do it on our own. And there's been a lot of work done at CGO with the fence and concrete and just the whole management of that. So, I mean, I could go on and on. I could fill this page with a bunch of names. I just picked a few that stood out to me at the time that I thought about it. So thank you, volunteers. You guys make this thing run. So this is usually where I talk about the next meeting. The next meeting is huge. First, I want to point out that note the new meeting date. We are not having an October meeting at all. So our October meeting is September 29th. At 6:30, we're going to start, not the regular 7 o'clock, because we have a lot of history to talk about, and that's what we're going to do. Plus, we've invited Carol Iorg from the Astronomical League. He's the president of the Astronomical League. He's coming in, and he's going to give a keynote. So, you know, 2.5 hours is full. And we've got a few people that are going to talk about, you know, Dave Faulkner, Ron Schmidt, and I think there's others that are going to be lined up to talk about the MAS, our 50 years. How'd we start? Where were the first meetings held? All those things. How did we wind up at Eagle Lake? Where did Cherry Grove come from? How did we establish a relationship with LLCC? All those things are going to be talked about next month. Well, okay, in 4 weeks. We're going to be back here. And we're talking about cupcakes yet. Just got to figure out how we're going to work that out. So in this whole, well, because we can't have cake. No sharing. So then we're also going to, I thought I pushed the button. Is that twice? Nice work. Okay, did you know? Okay. So then on Saturday, 2 things, well, 3 things. We're going to celebrate more with the 50th anniversary. It's Astronomy Day. It's International Observe the Moon Night. I know everybody gets excited about the moon, especially the public, and that's what we're all about. So we're going to have a program at ELO, and that program includes speakers again. We're having a food truck, so that's the part that gets me most excited because it's food. And if you can't tell, those of you online can't see me unless I'm standing in front of the camera. You know, I never miss a meal. And when somebody says food and food truck, I start getting excited. So we're actually going to have some barbecue. The menus are still a little bit in the air, but we're going to split that. I'm pretty sure it's going to be like beef and chicken type menu. It's going to be a sandwich, a couple sides, a drink, maybe a dessert, something like that. And we're going to charge $20 for that. I've talked to Vaults about setting something up on the email or on the website about having you buy tickets ahead of time, because I need to know how many of you are showing up. You know, I can't tell the caterer that there's 50 showing up and then 100 of you hungry people show up. Somebody's going to get in trouble then. And that's when I'm going to go running for the hills. So if you're interested, Vaults, how long do you think we can get that set up? A couple days? Yeah, so in a couple days, and I will say by the time we have our weekly email that goes out next week, we'll have the explicit details in there. But somewhere on the website connected with the 50th anniversary, there will be a link to the PayPal page. And there you will be able to buy your ticket. And with that ticket, then either you're going to show your receipt or provide a paper receipt, and you will be granted. And then we're also going to open it up. So, I mean, if you can't decide whether or not you're going to be there that day or not, if you show up, I'm sure we'll have some extras. We just need a rough, plus or minus 25 count, I think is what they're looking for, to make sure we have enough food for everyone. And again, we're going to have the regular prizes that we usually do for Astronomy Day, telescopes and books and MAS garb. All of that stuff is going to be given away. And we're going to do that. Okay, Dave has a question.
I believe that it's at 8:30. That's going to be a door prize and not a raffle. We're not selling tickets for it.
Yeah, no tickets sold.
No tickets for it. Must be present to win.
Correct.
Right. I just wanted to make that correction.
Thank you.
Yeah.
Yeah, there's a difference between a raffle and a door prize. Or prize drawing. Yeah, it's kind of, you have a ticket, you get something. How's that? And then there's a laser light show and then observing, of course. And, we won't close the observatory until the last person goes home. Isn't that right, Merle? Merle gave me the thumbs up. So that's good. So, that's going to be a party. And then the party is going to continue even to the next meeting on November 3rd, which is back to our regularly scheduled program for November. Kenneth Carpenter, the current Hubble Telescope System Scientist, is going to be our speaker. And he's going to talk about Hubble. And that should be great. Looking forward to that talk. Any questions from anybody in the room? Any questions, anybody online? Okay, I'm moving on. Oh, that's the next meeting. Right here again.
Now I have a question, Mark.
Yes.
So you mentioned the star party at ELO. Weren't we also having star parties at other locations on that weekend?
Yes. It's kind of been left up to the sites if they want to have a star party there. I know there's a star party that we are working on in conjunction with our establishing a relationship with Cedar Creek. So there'll be a star party there and that'll be advertised. That's planned for Friday. And nothing there then on Saturday night.
Right. And Suresh was going to do something out at
Suresh is not going to do anything with the BSIG.
Okay. Anything down at Cherry Grove?
Cherry Grove, maybe if they get organized, yeah, there could be something, but that'd be a members only thing because that's a members only spot. So I can't discount it. So yes, that's kind of a moving target, I will admit.
Okay.
Just a reminder that there's a Slack tool for collaboration that's up and running. There's an email address. If you're interested in subscribing, you must be a member to subscribe. The MAS is on YouTube. The best way to find it is by doing a browser search for Minnesota Astronomical Society on YouTube. And it works every time. And it works. Waltz has an update on the migration of the forum.
Okay, as you know, we've been this year doing a lot of cleanup on our IT infrastructure, and one of the last pieces is the MAS forum. So we contracted consultants to move the forum to the latest version of PHP BB software with the latest version of PHP, and it's running on our standardized cloud-based web server now. And so it's running right now in sandbox mode. So it's not accessible to the public. However, we're just doing our last debug where Clayton's looking at some of the admin side of things, and we're looking at the security thing. And I'm thinking, I don't have a target date from the consultant when we're going to actually flip the switch. But what we're going to do is put announcements on the forum. I'll put an announcement on the web page. We'll put it out on Slack, all the tools that we've got. And the forum will be shut down at that point, the old forum. So the old forum databases, so all of the old messages, every bit of history that's in the forum is going to get transferred to the new address. all the user databases. So everybody's username, everybody's passwords will get transferred over. And we've already verified that it does work. So it's just, it's going to get transferred over, and then we'll just make sure everything is working, and we'll shut the old form off and turn the new form on. And there is a new address. So the old forum address, as you can see, it's HTTP. So it's a not secure address, and it's forums.mnastro.org/forums. The new address, so everyone's going to have to change their bookmarks, is HTTPS forums.mnastro.org. So it's a little bit shorter, but it'll be under SSL security. Everything is good, and everything is the user serviceable. We'll be able to maintain it much easier, and it's all cloud-based. So everything is going to be everything is really good. So so far the sandbox is running cleanly. We're looking at it, and we're thinking the downtime will be 4 hours or less when we do that, and we'll give you ample time to to know that in advance. And when it's back up and running, we'll send out broadcast, whatever, with all the means that we have. But that's going to happen in the next couple of weeks.
I most likely suspect that it'll happen during the day.
It might
4
happen
hour.
at night. I don't know yet. I have to get the timing from these consultant guys do it at midnight all the time. So it might
Which would be
happen in the
kind of
middle
nice
the
if we're sleeping.
So, but we'll put out the addresses and the notices in advance. But the forum will be down for maintenance at some point in time for about 4 hours, and then you'll have to go to the new address. We'll try to put a redirect of the old address to jump to the new address, but we haven't tried that yet. So, but it shouldn't be that complex. But the best thing is to use the new HTTPS address.
Thanks, Waltz. I know a lot of work has gone into that, a lot of testing, a lot of stuff going on there. So, yeah, so I mean, that's going to be great. Eventually it's going to save us some money too, I understand. Maybe. So we'll shut off some old stuff. Anton is in the house to talk about the Loaner Scope program. Sorry, I should have given you a warning.
Well, just like always, we do have our Loaner Scope program. Members can borrow any number of telescopes for 1 month. We have Smith grains, Dobbs, and refractors, a solar scope, and a pair of binoculars. We also have DVDs of great courses that have been, actually, they're really good. I've watched a few, and everyone who's checked one of those out has enjoyed them as well. So to check out a telescope, go to our website and go to members, Loaner Scope, and there's a form to fill out. You can see pictures of all the telescopes. Make your selection, and that will send a message to me, and I will get in touch with you and arrange for a telescope pickup in my driveway. So, and questions?
Thank you, Anton. Tremendous service. When I joined the club, I borrowed a few. And that kind of led me to where I am today. Quite the rabbit hole that it created, but certainly a lot of fun. So check it out, especially you new members, and even you members that have been around a while. There might be something there that you want to check out. So use the program. That's what it's there for. Wear those things out so we can buy new ones. Sorry, Steve. I really didn't mean that, but well, you got to work on them when they're wore out. A little brief thing about COVID. As hard as we try, we had an incident from NSF, and so far so good. I haven't heard anything bad that has happened, but it happens, and it's going to happen, and it's going to continue to happen. So all we can do is, if we're sick or come in contact with somebody that's been sick, is stay away. Events before next meeting. I kind of had fun with this because there's two oppositions. The opposition of Neptune and the opposition of Jupiter. That just means that Jupiter is going to be up after the sun goes down. And that means it's going to get high in the sky before it's time for me to go to bed. And then autumnal equinox is in there too. That's as a astrophotographer, I get excited about that because then we start approaching more and more hours of pure darkness around new moon for pictures or bad data. I'm not sure which. So check those out. Also, another reminder right there on that slide, September 29th is our next meeting, not October, whatever it is, that first Monday. Was it like the 3rd, I believe? So September 29th, mark your calendars. You can't say you didn't hear it here. And it's, more 50th anniversary stuff. So check those items out and take some pictures. It's my line. So star parties that are happening soon, coming up before our next meeting. There's the September 3rd star party this weekend at Eagle Lake. September 10th is the BSIG at Metcalf Field. Saturday is the primary day, but if it's cloudy or predicted to be cloudy, Suresh will send out an announcement and he'll back that up and make it Friday instead, if Friday is clear. And then there's another star party at Eagle Lake on September 17th. And then there's 2 member weekends up at LLCC for those that are interested. Looks like 4th quarter moon and new moon there. And then CGO is always open. Okay. Are we? Trina's talking about the mini Messier sometime in September, possibly. So watch that email. She will include that in the weekly email if that's going to happen. Okay. The mini Messier marathon at CGO is the 23rd and 24th. One day or the other. And actually, it's up to the organizer as to decide which day. Oh, yeah. So the organizer says that it's too early to call as to which day it's going to be because of the weather forecast doesn't go out that far yet or is unreliable. You keep it up, I'm going to give you the microphone. So it's going to include observatory training, warming room training. Oh, and a work party. Oh, most importantly, get the work done. Got to finish building the fences down there. So keep an eye out for that. Announcements will flow on that in all the outlets, the email, the forum, and Slack. Suresh, are you online? You want to talk about the upcoming beginners?
Yeah, I'm here. Yeah, so the next BSEG is scheduled for September 10th, as Mark had mentioned. The previous Friday is the backup in case Saturday's cloudy. We've got some already some early attendance. People have joined the trip roster for that. So if you're interested in joining, either drop me a note on the forum under the beginner special interest group, or drop me an email at sureshks1@msn.com. And just somebody had asked earlier, the October BSIG, we moved it off of October 1st at Metcalf so that people could attend the main event at ELO. So the October one is now scheduled for October 15th. So that's all I got.
Thanks, Suresh. As always, you do a terrific job out there. Getting our beginners up to speed, get them connected with somebody that has some experience so that they start learning. That was a program that even I, and I'm sure many others in this room even, were part of at some point in their membership. So it's a great opportunity to get out with somebody that has some experience and learn what the night sky can bring them. Special announcement left over even from last month, but I want to hit this a little bit because it runs out at the end of this month. There's a 10% discount with Feather Touch or with Starlight Instruments, who sells Feather Touch focusers, there's a 10% discount, and that code is Club 10. Just put that they have when you check out, there's a little box for a coupon code, and you put the coupon code in, and you should get 10% off. And if you don't, send them an email. They're very responsive. They've been good to us. Another public service announcement, CGO imaging rig. We've been trying to get more and more usage to that platform. And so the only way we can do that is by having training. And my understanding is training is planned for September 16th and 17th, depending upon which day is clear, because it's really beneficial to have a clear night to run that rig and understand all its crazy little nuances of running an imaging rig. You can sign up there by sending an email to cgo-imaging@mnastro.org. It's a great rig. We're still fine tuning it a little bit, but I've seen some images off of it recently, and it's doing all right. Another public service announcement related to one of our members, Michael Copper. Michael has been working to try and get sidewalk astronomy back going again, and he wants to do it in association with the MAS, and just promote the whole thing that the MAS is alive and well. Michael has established a contact with the people from Pershing Field Park. The address is there. Last I heard was October 1st, but October 1st is also Astronomy Day. I thought he was working on switching.
He updated on the chat saying it's
Yeah.
the 24th.
Yeah, so Michael, if you're online, you take a couple minutes and just explain what you got going. I mean, you've been working on this for 2 months, so.
I'm here. Can people hear me?
Yes,
Hello?
we can hear you just fine.
Great. Yeah. I have been working on this for more than 10 years, a really long time ago, decades ago. Before I owned a telescope, I attended an MAS star party at Lake Harriet right near the band shell. And it was incredibly nice, and a huge number of people came out. The lines went all the way across the parking lot. And I don't know why, but the park people, somebody stopped doing it. Either we stopped or they stopped. I've heard that it was the park people who quit because it tended, being in the summer, when it gets dark late, it tended to go past their 10 p.m. parking limitation. But Susan Susag at Pershing Field Park, she's only been working at Pershing Field. She's been the director there for 2 years. So maybe she didn't know that other park people had said no to this. I was very honest with her, and she really is excited about doing it. She's talking about doing it in September and then doing it again. I told her that on October 1st, we'd have Jupiter, Saturn, and a first quarter moon, which is like perfect for showing to the public. But then I understood that we're going to have the 50th anniversary, and I was thinking about maybe those could be confined. But my latest idea is to just not compete with ELO. And I think we should just move to September 24th. We'll still have Jupiter and Saturn, beautiful and totally available in the sky. And we won't have the moon, but maybe we can get the moon next year. You were right when you said the public loves the moon, but they love Jupiter and Saturn. This last weekend, I was doing Jupiter and Saturn at St. Radigan's Fair down in Mankato, Minnesota, and people loved it. They were just so excited. People came back and got in line like 5 times just to see them again. So I think it's going to be September 24th 8:30 p.m. to 10:30 p.m. And I have no idea how big it's going to be. Decades ago, the one at Lake Harriet was huge and there were dozens of telescopes. So I really am urging people to come out. Now, we don't know what'll happen. We might have more telescopes than members of the public, but I've been teaching astronomy for a long time. And the first thing that everybody asks me is, where can I go and see the stars in the city? And I always tell them, you should go to Eagle Lake Observatory. Amazing telescopes, great astronomers. They're much better astronomers than I am. They can show you the sky. They can tell you what you're looking at. If you ask them to look at something, they'll show you, they'll show it to you and they'll tell you what it is. But people, they don't come out to ELO. My astronomy students don't, my neighbors don't, my friends very rarely do. For your typical member of the public who loves the sky, it's just a little bit too much. But I think they're going to come to Pershing Field by the hundreds. So we could really use some telescopes.
Thank you, Michael. You know, members, there's even you new members, there's nothing wrong with you showing up with a telescope, because under a little pressure from the public, it's amazing what you can learn. And there's nothing wrong with saying, I don't know. But, there's might be somebody there with you that can help you out. But it's a perfect opportunity to start sharing. I mean, that is what we're all about, is sharing the sky with the public. Michael, it's the 24th, so it's the weekend before our big shindig at ELO. And, I know I can't make it. I already have that weekend tied up. But I'm sure there are others. There's lots of telescopes in this club. I saw the field at NSF. Don't tell me there's no telescopes. So thank you, Michael. We're going to do our best. September 24th starts at 8:30, Pershing Field. Bring your telescope, be there. Help out Michael. Let's get it going. I'm excited about sidewalk astronomy. So thanks, Michael, for getting that going. Tremendous. Thank you. Moving on. So some help wanted. I understand that they're building the lunar landing module mock-up. I should proofread my slides. Maybe I should give them to somebody else. Proofread my slides before I send them. The landing module at the landing module mock-up at ELO is being built again. So it's the Apollo 11 module, right, Merle? So they're rebuilding. We did it a few years ago in 2019. That was the 50th year of the Apollo 11 landing. They're building the same thing again in honor of the 50th, the last lunar landing 50 years ago, Apollo 17. So they need some bodies to help reassemble it. Big push the next couple of weeks because they want to have it done for their September 17th star party, and then again for our astronomy day star party. And then I have no idea what's going to happen. I heard bonfire, but I don't think the park's going to go for that. So I imagine it will be just going away. My understanding is that there's work parties scheduled or going to be scheduled. And if you're interested in helping, watch the ELO discussion forums for those details. It'll give times and needs, power tools, whatever, hammers. Bro? Okay, 11 o'clock this coming Saturday. There will be a work party to continue the assembly. So check that out. You can respond to let Merle know that you're coming. That'd be kind of nice. I think he would appreciate that. But 11 o'clock is the start time. there's a star party that night too. So you could stay, have dinner, spend the night under the stars. And there's moon. There's a first quarter moon. So very cool. So more help wanted. So we're looking also for astronomy day. We're going to need help. We got to get the place ship shape first, and then we got to put on the party. So we're going to need some members to help staff those events. And again, Merle will take care of posting what he needs, and you can sign up and let him know that you're going to be there. You know, doesn't take any amount of expertise to say the classroom is over there, telescopes are over there, the bathroom is down by the lake, you know, all those things, you know, to just direct traffic. We need somebody to do that too. Answer questions. Again, you don't have to be an expert about ELO to help out there. And it's a fun place to be when there's a lot of people. So again, check the forms. There's details. Gemini articles. Now, this month and next month, Father Brown is looking for, well, even early November, but I wasn't going to let it go too close to the deadline. Father Brown is looking for specific articles and stories from founding members and longtime members to tell the story about the club. Talk about your experiences. Talk about the MAS and how it's affected your life, maybe. There's all kinds of opportunities. I know in the beginning, there was a lot of you telescope builders, and there was a lot of things going on there. That's way before my time, but I know there was lots of parties to build mirrors and grind mirrors and coat mirrors and test mirrors. So, you know, I'm looking forward to those kinds of stories. So if you have an idea, contact Father Brown or just send them the story, and you can get his email address to send that story. It's in the Gemini, and the Gemini is on the web. If you just do a search on our homepage, you'll find it, and you can send him that article or even just establish contact. So let's fill it up. Let's make it big, a big Gemini.
This is Father Brown.
Oh, wow. Hello, Father Brown.
I've received a couple of articles about the history of MAS, and along with other things for the October issue, it looks like that will be filled. So we're looking now for December, which is the deadline is November 10th. So please send me an article about whatever your experience has been with MAS, regardless of whether you've been a member for 50 years or 40 or 10. And if I get more articles, then we'll fit in either the October or the November issues. We will have them for issues in 2023. So send me lots of articles about your experience with MAS. Thank you.
Thank you, Father Brown. As always, the Gemini is always a treat to read every quarter. Oh, I guess I get it more often than I think then. So we do weekly emails. I'm getting harassed in the room. I just want everybody to know online. We send weekly emails out every Tuesday. Our secretary, Trina Johnson, prepares those emails. She likes to have that information by Thursday. Some people, I won't mention any names, kind of send her stuff even on Tuesday before lunch and ask her to squeeze it in there. Yes, guilty as charged. I feel the finger pointing at me. So also, I know she's still working on trimming the, so if you felt like there's a 3-day weekend coming up, so she's going to work on the list again. She's trimming it down just because it's massive and it's kind of getting out of hand. And we're going to start reaching limits with our nonprofit account that we have through MailChimp. So she's paring down the list. And so send your email if you want to continue to be subscribed. Thank you. Astronomical League awards Jerry Jones, MAS Astro League coordinator. Please come forward.
Good evening, everyone. You too, Mark. I actually lied to Mark earlier. He told me that he asked, so I only have one, right? And I discovered that I have three. Actually, I have only two, and one is an honorable mention, which we will start with. Trina Johnson, an honorable mention for the Northern Constellation Hunter. Let's give her a round of applause. She forgot to bring her certificate tonight, hence the reason why it's only an honorable mention. So anyway, I have two others. We've been having actually quite a number of master things going on. Dave tossed us in a little while back, received his gold and his silver master level. And we have another master that I have the pleasure of presenting to Brad Nessett, the master level outreach. Brad, come on up. Congratulations. Would you be kind enough to tell the powers that be here just what was involved in you getting your master outreach?
It's really quite easy. The outreach program has three parts of it. The first one is the basic level. The second one is whatever it's called, and the third level is this one is the master level. And what you have to do is just enjoy yourself and enjoy talking to people. And pretty soon here you are standing here receiving this.
Simple as that. Huh?
Simple as that.
I suppose it's helpful to have a telescope with you and people around.
Yeah.
Right. Yeah. Well done.
Yeah.
Congratulations.
Okay.
Fantastic.
Thank
Thank you. So this next one's kind of cool. The Astronomical League on a quasi-regular basis adds other observing projects to their list to help provide additional incentive and additional avenues for observers to become involved in different levels and different types of observing. One of the more recent observing projects that they put together is called the Spectroscopy Observing Project. And typically, one of the bigwigs winds up getting, obviously has to go through the project, make sure it works, make sure everything is there. And so generally the number one and number two and number three are the bigwigs like Aaron Clevenson and those kind of guys all get number one. Well, we happen to have in our midst the Spectroscopy Observing Program number 2. Ooh. Which belongs to none other than our very own Anton Gregory. Anton, come on up. This is pretty cool. It says for observing, recording, and interpreting the spectra of astronomical objects, certificate number 2, August 3rd, 2022. Congratulations. That's pretty awesome. Feel free, please give us a little bit of information about what's involved in this observing project.
Okay, this project has 3 parts to it. The first part requires that you capture the spectrum of 3 stars in each of the spectral classifications, O, B, A, and so on. The and the G stars have to include the sun. The second part is special projects, and there's a laundry list you can choose from, or you can make up your own. I chose to capture the spectrum of the atmosphere of Uranus, and I could barely plainly see the methane lines in the red end of the spectrum. And I also spent an evening capturing the spectra of RR Lyra as it changed its size and shape and temperature over the course of the night. I could see real changes in the spectra from the beginning of the night until dawn. And then the last part, which is most challenging, had to capture this the spectrum of 5 eclipsing binaries, both the primary and the secondary occults. Now, what made this so challenging is that in addition to all the usual hurdles that we have, the target has to be available, we need good weather, we need personal availability. Well, this adds on top of that, you have to be there at the right moment. And so this part took a long time to finish before I finally got all 10 of these occultations. If anybody's, I'm sure someone asked me how I did this. Well, most of my observations were done with my 8-inch Newtonian on a clock-driven equatorial mount, a monochrome planetary camera with a diffraction grating. That was the equipment. I used SharpCap to capture the images, Serial to register and stack them, and the RSpec software to process the spectrum.
Fantastic. So if somebody is interested in what sort of observer would you encourage to consider this? Because this really is not a normal observing project. I mean, normal in the sense that you put your old eye to the eyepiece and either sketch it or you write it down or you put a filter on that kind of. It seems a little more complicated or a little more involved. So do you have any opinions as to who would be most drawn to this project?
Yeah, well, I suppose those who are really interested in the astrophysics behind the things that we look at. Yes. I use the SA 100.
Repeat the question.
Oh, yes. It was asking which grading did I use? So it's 100 millimeter or 100 lines per millimeter SA 100 from Tom Field's RSpec. Yeah. And anyway, as I was saying, probably those who are interested in the astrophysics, I find that fascinating. I've taken several classes in it, and I was frankly honored that Professor Roberta Humphreys, anybody out here know Roberta Humphreys? Yes, she's an internationally renowned spectroscopist. She took me on as her student last year and guided me through a self-study in spectroscopy.
That's pretty cool. Well, well done. Well done. Congratulations. And as always, get out there and observe.
Thank you, Jerry. There's your slide. Better know a constellation. We're looking for a volunteer. Contact me, please. This is a great program, a great opportunity even for new members, because, you get to go do research on a constellation and then present it to the rest of us. And I've done it a few times. I did it a few times when I was a newbie. And, the biggest part is don't be shy. Don't worry. Don't worry about what somebody's going to say, because, there's no grades handed out. There's only applause. So that's all I have to say about that. Contact me if you're interested in taking on this project. And you don't have to do it every month. We can rotate it. I'd love to see 6 people sign up and say, hey, put me in line. That would be fun. So next month, guess what? What time? When is the meeting next month? It's not next month. It's this month on the 29th. What time is the meeting? 6:30. All right. So I got it across in this room. Now I just have to work online a little bit. So we're going to talk about the timeline of the MAS, and Carol Org is going to be here. I don't know which topic he proposed 2 topics to me. One of them was just Astronomical League history and stuff like that. I'm trying to get him to do that on Thursday night and then do his other talk on Saturday night at ELO. But I have to work those details out with him yet, because I got to find out which one's longer. Because we want the short one on the 29th, because we're going to be squeezed for time. So I look forward to that. So tonight we have a feature presentation with Dennis Conti here with us. I believe he's online, and he's going to take over the show here in a second. But he's from the American Association for Variable Star Observers. And his topic tonight is the role of astronomers, amateur astronomers have played in exoplanet discoveries. So please welcome Dennis to the show. Dennis, I'm going to quit sharing. If I can figure out how to do that. Right there. And you can take over and share your screen, and the floor is yours. And we'll open it for questions at the end, or if Dennis wants to take questions as he goes along, that's up to him. But I'm going to sit down and shut up now.
Okay, thank you. Can everybody hear me okay?
Yes.
Okay, thank you. Well, first of all, pleasure to meet with all of you this evening, and congratulations on your 50th anniversary that I think was mentioned before. Put your birth right in the middle of the, or I guess towards the end of the Apollo program, which is, I think, what got many of us interested in space and astronomy and wanting to be astronauts and all of that good stuff. So congratulations to all of you. Let me first begin with my own journey as to how I got involved in exoplanet observations, which may relate to many of your own experiences. Many years ago, I started into telescope observing, visual observing, that got into imaging, was doing a lot of deep sky imaging, astroimaging, planetary imaging. And about 7-8 years ago, I was on the ALPO forum, that is the Planetary Observers Forum. And there was a lot of discussion about those of us who were at the time observing Jupiter, when Jupiter was not in a good field of view, what should we be doing? And somebody on the forum suggested we should be observing exoplanets. Now, of course, I kind of scratched my head and thought, wait a minute, from my backyard telescope, I'm able to observe a planet going around a distant star. But lo and behold, I dove into that field. And my first observation, I was just stunned that I could in fact see an indication of a planet going around a star outside of our solar system. And in fact, what you see here, this dip in light, is in fact indicative of a planet, in this case, WASP-12, going around its host star. So indeed, with a backyard telescope, in my case, it was an 11-inch Celestron telescope in suburban Annapolis, Maryland, so the skies are not that dark, being able to detect the transit of an exoplanet. So again, that led me into exoplanet observing. I presented some observations at my local astronomy club, then got involved with professionals. And one thing led to another, got me very deep into exoplanet observing. What I'd like to discuss tonight, as the title of the presentation suggests, is how we amateurs have been an integral part of the discoveries of exoplanets over the last 6-7 years. And really is a very, very strong role, as you'll see coming up in the more recent past, especially with the TESS satellite that was launched about 4 years ago. So before I get into it, let me just say a few words about the AVSO, American Association of Variable Star Observers. It's kind of a long name. Variable star means really a large, broad number of topics, not just stars that might pulsate or that might vary over long periods of time, but even things like exoplanets, which in effect is varying the light of a star. The AVSO is an international organization of amateur astronomers, and its primary focus is to advance the science of astronomy through collaborations we have with professionals. We have long-term databases, both of variable stars, as well as more recently exoplanets and spectroscopy. We have publications that are entered into the Journal of the AVSO by both amateurs and professionals. We have many tools, training courses, various other resources, including software to help our members make science grade observations. And we have biannual meetings to provide a way for us to interact both in person and virtually. In fact, one is coming up this coming November. Finally, the heart of the AVSO are our sections. We have sections in a number of fields, as you'll see in a minute, that provides a way to connect members with each other in various common areas of interest. And these sections, just like you indicated on your own club format, do have forums for communicating with each other of common issues, questions, and so on. The sections vary from those involved with different types of variables, variable stars, including eclipsing binaries, exoplanets, which is going to be the topic of my discussion this evening, and everything ranging from long period variables to even solar activities. And a more recent one is a spectroscopy section, which is devoted to helping our members gain experience in spectroscopy and storing their images, storing their results in databases. So let me focus then on exoplanets. The exoplanet section provides training and support to our members in conducting observations and research. We also have a database where we store our results for the professional community, especially to take a look at the refinement of the period of exoplanets. And I'll get a little bit more into that. As I said, various resources to help our members. All right, well, let me kind of back up and talk about the big picture. We sometimes get involved too much with kind of the bits and bytes of data that we're collecting and observations we're doing. Let me just sort of step back for a moment and just remind everyone that what NASA is really trying to do in its long term is, of course, to see if we can discover planets outside of our solar system that support life. Now, related questions to that would be, can we find a planet that's rocky, that is to say that has some kind of hard surface? Can that planet support liquid water, since we believe that's sort of fundamental to any kind of life? Does it have an atmosphere? Does the atmosphere contain biosignatures that we could recognize as potential signatures of life? And that would be something like not only oxygen and methane, but other types of elements that we think are characteristic of life. One of the, in fact, issues right now that exoplanet scientists are dealing with is that we're finding that what we thought were biosignatures that were indicative of life, such as oxygen and methane, we now see that some of those can be actually caused by non-biological processes. So that sort of complicates the issue of what's a real signature of life. And there, in fact, are some folks who are now looking at technosignatures. That is to say, if there's a intelligent life out there, that there may be some signals from a technological point of view as opposed to from a biological point of view that might indicate life. But what we're focusing here on are more the biological signatures. Now, the final question is, what is life? What form of life might exist? Let me sort of depart for a moment and talk about different types of life here on Earth. And in fact, extreme forms of life. Many of you, I'm sure, have heard of life that existed in the deep oceans in or near hydrothermal vents. One of the examples is something called a tardigrade, this little woolly bear looking thing about 0.5 millimeter long that we now find is able to withstand radiation as well as extreme pressure and temperature. If we extrapolate from our own Earth and some of the extreme environments that tardigrades, for example, are able to live on here on Earth, and take a look at, even within our solar system, something like Saturn's moon, Enceladus, where we know that there's, or we believe there's now a ocean under an ice crust because we've seen plumes of dust and volatiles coming out from the surface. Could it be that, for example, extreme forms of life exist in those oceans? So even though I'm focusing on life outside of our solar system and talking about that, we mustn't forget that even within our own solar system, there's a possibility of some form of life. It might not be little woolly bears like our little tardigrade here. Maybe it's some other kinds of microorganisms. So I just wanted to step back and just talk about the questions that really are driving NASA's mission. And as we'll see in a minute, we're well within that list of answering those questions. Now, if we take a look at the night sky and we take a look at all the stars that are visible to us, astronomers now believe that close to 90% of those stars have a planet going around them. If not one planet, perhaps multiple. From our point of view, some of those planets have orbits that are circular, where the planet is not passing in front of the star from our point of view. Some may have planets that come close to passing in front of the star, and some stars have planets where, from our line of sight, the planet passes directly in front of the star. It's that last category of planets and stars that I'm mostly going to be talking about this evening. And in fact, it's mostly those planets that NASA has discovered because they're more obviously able to be observable from Earth. So if we look at the different kinds of exoplanets, some of the more common ones that have been discovered, mostly because they've been the easier ones to discover, are planets that are very close to their host star, so-called hot Jupiters. And they're, of course, named that because they're Jupiter-sized planets. They're not Earth-like planets. And they're very close to their host star. So their orbits are on the orders of days, not years in Earth terms. Now, it's obviously not possible for life most likely to occur on those planets, but nevertheless, this is a rather recent discovery that there are a large number of planets that exist in this way, and it's not clear why, from a planet formation point of view, a large Jupiter-sized planet was able to form around a host star. We usually think of Jupiter-type planets like our own further out from their host star. But nevertheless, these are a large number of planets of this type. A more fruitful one from the standpoint of possibility of habitability are ones that stars have multiple planets where the star itself is a cooler star. So the planets can operate in more of a habitable zone, being closer to the host star. And therefore, we're able to observe those as well. The most famous one is the TRAPPIST system. The TRAPPIST system, in fact, is one of the key planetary systems that the James Webb telescope is going to be focusing on in the very near future here, because this is one of the examples of a possible set of planets that possess liquid water and are in perhaps a habitable zone. We have the case where we have planets that orbit a star that itself orbits another star. So we have multiple star systems, and in fact, quite a few of these. We have some free-floating planets that we're not quite sure why these planets have been ejected from their host solar system. And we have some interesting planets that orbit opposite the direction of their host star's rotation, which is sort of counterintuitive because usually a planet is formed as part of the circumstellar disk where the rotation of the star in its formation also creates planets in the same orbital orientation. These could be star planets that have been, for example, captured by host stars. So we have some weird cases like that. And finally, we have some examples of planets that are disintegrating around their host star. So this sort of shows you that when we talk about exoplanets, there's a wide variety of different types of planets. Now, the ones that, as I said earlier, we're going to be focusing on, and the one that is the dominant method that not only amateur astronomers, but professional astronomers have observed, are those that transit directly in front of their star. And as you see here, as the planet does orbit in front of its host star, the light of the host star dips in sort of a typical bucket-shaped curve. And we're able to, out of that curve, get a lot of information about the planet. Specifically, based on the duration of the dip in light, based on the depth, and even based on the shape, we're able to get information about the radius of the planet, that is to say the planet's size. We're able to get information about the size of the orbit of the planet and the inclination of the planet's orbit relative to our line of sight. Now, an important point here is that I said that we're able to get information about the radius of the planet. What we're not able to get with the transit method is a measure of the mass of the planet. Now, why is that important? Well, if I have the radius and I have the mass, I'm able to determine its bulk density, which will give me some indication of whether the planet is rocky or not, which answers one of those preliminary questions I presented earlier as to what are some of the questions NASA is trying to answer about the existence of life. So we get radius with the transit method, but not mass. We can get mass with another method using spectroscopy called the radial velocity method, which is a method for determining, estimating the mass of the planet. And if we have time later, I'll be happy to go into that. So these are some of the types of parameters about a planet that we're able to determine just simply based upon the light curve of that planet. Now, let me say a few words about TESS. TESS is the Transited Exoplanet Survey Satellite. This is a satellite that NASA launched in 2018. It's still in existence, still operating quite well. It, as the name implies, has been doing an all-sky survey to look at relatively near bright stars as to whether there are transiting planets around those stars. TESS has 4 cameras, and it will dwell on a sector of each hemisphere for a period of 27 days, and then move to the next sector. It has now done a survey of the entire sky twice and has discovered thousands of planet candidates. Now, when I say candidates, I'm not saying confirmed. And that's a large part of the rest of my talk we'll get into in a minute, that TESS is able to detect that there is a star or a area in its camera field of view that has seen a dip in light and then needs to go through a confirmation process to determine indeed this is a planet. And this is where we amateur astronomers play a large role, is helping TESS, for example, confirm that what it sees is indeed a planet and not a false positive. Now, I mentioned that the TESS satellite dwells on each region for 27 days. What that implies is that it's able to then see if it sees a dip in light, let's say at least twice, then that would be indicative of a planet. If it sees it once, it could be maybe an eclipsing binary. It could be some other false positive, but that implies that for seeing it at least twice means that the orbital period of 13 days would be the most that it would be able to detect a period for a planet. However, at the very pole, the ecliptic pole, as you see in this picture, there's a continuous field of view of TESS. And here it's able to detect planets with more than 13-day periods. And in fact, many of the candidates that TESS has discovered for the Webb telescope to look at come from this continuous viewing area. So TESS is sort of the workhorse that has been more recently discovering planet candidates that we are confirming that then become candidates for James Webb to look at their atmosphere. And I'll touch on the Webb Space Telescope in a minute. As I said, TESS was launched 4 years ago, looking at stars, bright stars within 30 to 300 light years of Earth. The purpose of TESS has been to present candidates for Webb to characterize the atmospheres. As you probably know by now, James Webb does not look at the universe in the optical. It looks at it in the infrared and near infrared. So what James Webb is doing with respect to exoplanets is looking at the atmosphere of exoplanets to determine the elements in those atmospheres. Again, going back to one of the original questions I posed, that gets to the third question. Can we detect biosignatures in the atmosphere? So what Webb is doing is taking some of the confirmed test planets and dwelling on them to look at the constituent parts of the atmosphere of those planets. So far, TESS has come up with over 5,800 planet candidates and 231 confirmed exoplanets. And this number just keeps changing every week. Now, the process to go from candidate to confirm, as I said, is where we play a huge role. And by huge, I mean literally probably more than half of the observations that are being made for follow-up to help with the TESS science team are done by amateur astronomers. Now, why do we need ground-based observations when we've got this great, big, beautiful telescope in the sky called TESS? Well, in order to do a all-sky survey, TESS has to have very large pixels. And in doing a survey with large pixels, what's going to happen is that multiple stars or the light from multiple stars can be blended together in a single TESS image, let alone a single TESS pixel. So a dip in light that TESS might see can be caused by maybe an exoplanet transit, or it could be various other types of false positives, which I'll present some examples in shortly. So what we need to do is that when TESS identifies a planet candidate, part of the pipeline to confirm it is that we on the ground do follow-up observations to sort out whether those dips in light are due to exoplanets or whether they're due to other false positives. The reason is because, quite simply, our imaging is a higher resolution than TESS. Those of you who do deep sky imaging are probably imaging with pixel scales on the order of 0.8 arc seconds per pixel or 1 arc second per pixel. TESS's image scale is 21 arc seconds per pixel. So you can see that observations on Earth have a higher resolution than what TESS has. To give you the big picture with TESS's pipeline, the first step after TESS has come up with a planet candidate is the ground-based observers, such as amateur astronomers, first of all, work through a number of different possibilities to rule out any false positives, or as many as we can. After that, it goes to higher resolution imaging involving professional observatories, and then spectroscopy to characterize the light of or to characterize the star a little bit better. And finally, to spectroscopy to determine the mass. As I said earlier, this is one of the critical components in determining density. So where we play a role is this first step, which is the most critical step in the pipeline because we have to rule out as much as we can any false positives so we don't tie up any valuable time on any of the professional observatories. Now, to dive a little bit deeper into this issue of the difference in resolution, this is actually an image I took of a potential exoplanet from my backyard telescope. If you take a look at the two stars in the middle, and we zoom in on them, you'll see the little squares are my pixels, which are about 1 arc second in length. And if I now look at what a test pixel is, let's say covering these two stars, the test pixel is going to cover both stars. So if I see a dip in light on a test pixel, I'm not sure which star is coming from. Whereas if I now take an image of that same host star with the planet transiting it, I'm able to at least resolve which star that dip in light might be occurring. So this is like what a test pixel would look like. Now it gets even more complicated because what happens next, both with tests and us ground-based observers, is we do differential photometry. And for those of you who aren't aware of what differential photometry is, it's basically taking a look at the light coming from a star, comparing it to other stars, and determining the relative magnitude or changes in magnitude of that star. The photometric aperture that we would use on Earth, for example, would be what you might see here in this little white rectangle. Not only is Tess's pixel larger, but its photometric aperture is larger. So from a test point of view, the blending gets even worse. So both from the standpoint of large test pixel and large test aperture, the problem of blending makes it a little bit more challenging to determine whether Tess's dip in light that it's seeing is in fact coming from a particular star or in fact indeed is due to an exoplanet transit. Now I mentioned that there are possibilities of different false positives that occur because of this blending. One of the more common is where I have a target star with a nearby eclipsing binary. That is to say, I have a target star and I have two stars that are eclipsing each other. If these are blended together from a test point of view, the test just sees one blob of light and it sees some dip in light. It's not able to determine whether the dip in light is occurring from the target star or from the eclipsing binary. However, on Earth, if we're able to resolve the target star and the eclipsing binary, we can in fact then determine that indeed that transit or that dip in light is not occurring from the host star, is occurring from the eclipsing binary. So what amateur astronomers are doing are sort of indirectly confirming the negative. That is to say, they're ruling out that it's not coming from the host star. However, if we do see that the dip in light is occurring from the star on the left, then that is further confirmation that indeed there is a true transit happening and it's not just two stars eclipsing each other. This is one of the more common examples of false positives that we amateur astronomers on Earth are helping the test science team distinguish. I'll give an example of this in a minute. Another example is where the nearby eclipsing binary is so close to the host star that even on Earth, we're not able to resolve it. In that case, what we do is we defer that to the large professional observatories. Now, having said that, we amateur astronomers also are involved in getting back images from these large professional astronomers. I'm, for example, on a team of about half a dozen other amateurs that daily get images from 1 meter telescopes, for example, in some of the large LCO observatories. So we're able to help the test science team, not only using our own telescopes in the first case, but also to help with the analysis of images from these large professional observatories. Another false positive example is where we have what's called a hierarchical triple, where the a star, a target star, and a nearby eclipsing binary are orbiting each other. And so we have multiple transits happening. We have the eclipsing binary happening, and we have a host star passing in front of the eclipsing pair of binaries. So it becomes a much more complicated series of transits occurring. Another example is where the target star itself is an eclipsing binary, but there's a non-eclipsing binary next to it, but blended together, that combination mimics a transiting exoplanet. Another example is where there's an eclipsing binary alone, but the secondary star is small enough that it looks like it might be a planet. And this again is an example where from Earth, we're able to help distinguish that. And finally, we have the case where the secondary star grazes the primary star, and it makes it even a little bit more difficult because it's just seeing a smaller dip in light to distinguish from whether it's a planet or an eclipsing binary. So these are examples of false positives. How we detect the false positives, as I said earlier, just the shape of the light curve itself is a big hint. If we see a bucket-shaped curve, that's more indicative of an exoplanet as opposed to a V-shaped curve. If we see differences in alternating depths, especially if they're V-shaped, that's more indicative, again, of a eclipsing binary. If we see variations in color by using different filters, that's also indicative that it's more likely an eclipsing binary than a planet. So these are some techniques that we use with our ground-based telescopes to help detect whether what we're seeing is a false positive or not. And finally, if the depth of the curve is such that it's indicative of greater than 2.5 Jupiter radii, then more likely it's not an exoplanet. It's more likely an eclipsing binary. Now, to give you a real-life example, this is a light curve that one of my colleague amateur astronomer friends in upstate New York took of a particular object, did that with a red filter. And on an odd number of periods later, I took an observation in a blue filter. And if we superimpose both on top of each other, you see we have a chromaticity difference. And this would be proof positive that this indeed was a eclipsing binary that we're seeing and not a transiting exoplanet. In addition, of course, what gives it away is this characteristic V-shaped curve. So here we have both an example of really three things. The curve itself being V-shaped, the fact that alternating curves are of different depths, and the fact that there's a difference in chromaticity using different filters. So that sort of nailed the fact that this was an eclipsing binary and not an exoplanet transit. Now, to give a quantitative example, let's say we see from tests an object that produces a light curve with a depth of 10 parts per thousand. That same object, if we look at it from Earth, and we're able to really resolve the fact that there's really two parts to that light. There's a star and there's what we think is an eclipsing binary. The fact that if that one star had a magnitude of 11, and let's say that the eclipsing binary had a magnitude of 13.5. The light curve of that eclipsing binary would be 100 parts per thousand. Namely, what TESS saw as a 10 parts per thousand dip, if you take a look at it from Earth point of view and unblend, if you will, what's happening, it would be very clear that what's happening is there's a very deep V-shaped curve. So this would sort of nail again the fact that what looked like from TESS be an exoplanet is in fact a eclipsing binary or nearby eclipsing binary. So the numbers work out such that, I won't go through the math, but the numbers work out that the blending on the right produces a depth on the left that could look like a transiting exoplanet. Now, one of the difficulties is that if we look at a field of view around a target star, and this is a ground-based image, all of those green identified stars are within a radius, 2.5 arc-minute radius, such that they could be blended together to produce a mimicked exoplanet transit. So what we have to do on Earth is literally go through each one of those green stars and determine whether in fact it's an eclipsing binary. Well, that initially was a very tedious task that the TESS team was doing. What we did, that is to say the AVSO team did, was to develop software that actually automated that process, where that whole detection of whether there was any possible eclipsing binaries could occur on the order of minutes, as opposed to what was taking hours of manually checking each of those stars. So one major contribution we made to the TESS science team is to produce an automated way of doing these measurements. Now, the software that we use is primarily a piece of software called AstroImage-J. Is sort of the de facto standard for doing exoplanet observing and analysis that's used by both amateurs and professionals. This is an example of the output of the light curve that you see with the bucket-shaped curve. What you see on the bottom, which are the three black, green, and purple lines, are comparison stars. And that is to say, stars that are in the same field of view that show no variability. The idea is, in fact, as part of differential photometry, to not only take a look at the light curve of the target star, but also to make sure that what we're seeing is not the effect of changes in seeing or changes in transparency. So the whole philosophy of differential photometry is to also look at comparison stars. And what you see here is, of course, the comparison stars are non-varying, fairly straight line, whereas clearly the target has a characteristic bucket-shaped dip. And again, this was done from my backyard telescope in suburban Annapolis. And so we're able to detect exoplanet depths on the order of 10 parts per thousand or greater. And as I said earlier, one of the tools that we developed is this analysis tool to take a look at the entire field of view that could hold possible false positives. And what you see highlighted here, in fact, is an addition to AstroImage-J that we developed that are part of the software. So to sort of summarize, one of the other things that we did was actually to develop the guidelines for submitting observations. And a lot of those guidelines are being used now by the entire TESS team. As I said in the first bullet, as I mentioned, the majority of these submissions are being done by amateurs. On the third bullet, I mentioned that we did this automated process for looking at the field of view of potential nearby eclipsing binaries. And as I also mentioned, we're helping with the analysis of observations from remote professional observatories. So back to the AVSO. So many of the amateurs that are involved in tests came out of training courses that we offer in the AVSO. I have a guide on my website that is primarily involved with many folks like yourselves who have been doing deep sky imaging, who are used to doing guiding, who are used to doing astroimaging. And it sort of picks it up from there and kind of takes you through all the best practices of moving into exoplanet observing. And the second half of this guide also includes a tutorial on using AstroImage, that software package that I just mentioned a few minutes ago. We also have a qualification program for AVSO members who want to be part of the test science team. And so far, we've qualified 26 members to participate in tests. So where does all of this fit relative to future exoplanet missions? Well, obviously Webb has been in the news lately, and it's already started to characterize exoplanet atmospheres. You may have seen on the first day of the Webb rollout that there was a curve presented showing the atmospheric characterization of a particular exoplanet. And this was sort of a teaser to show what Webb will be doing for other exoplanets, being able to identify much more precisely than Hubble has been able to do some of the elements in the atmospheres of exoplanets. So Webb is up and running. It's running beautifully, and we hope to see a lot of science out of it for at least the next 10 years. Hopefully in later this decade, the Roman Space Telescope will be launched, and this will be one of the first times we'll be able to really start directly imaging exoplanet atmospheres. Now, there have been some attempts and with success to, when I say observe, by the way, what I'm talking about is be able to visually see some of the atmospheres as opposed to just sort of indirectly. Some of the very hot new planets that are orbiting a star have been directly imaged, but only a few of those. But hopefully with Roman Space Telescope, we'll be able to directly image exoplanets closer to their host star. So again, going back to the original set of questions that I posed, you can see that NASA is moving more and more toward answering those questions. You know, is the planet rocky? Does it have a, is the potential for holding liquid water? Does it have the elements in its atmosphere for possible life? So all of those questions are what's driving NASA's future missions. Okay, to summarize then, hopefully I think I've pressed upon you the value that we amateur astronomers have done in helping with exoplanet science. And by the way, this is continuing. I mean, this is not just, you know, the end of this year is going to be, we've got many, many more targets with tests. With Webb, there's a possibility of having to do simultaneous ground-based observations at the same time. Webb is doing space-based observations. So the future is just incredibly ripe for amateurs to be involved in exoplanet science. And I should mention that as we participate in ventures like TESS, where we are actively involved in doing observations, if our observations are used to either confirm an exoplanet or in fact to help discount that there's false positives, we become co-authors, or the opportunity to become co-authors with scientific papers. In fact, many of us have been now co-authors on numerous papers. I'm probably on about 24 papers that are organized by the professional community, but they have seen the value of amateur astronomer participation and have included us as co-authors. And the point I made earlier that at the astroimaging experience that many of you have, the planetary experience you have, is directly related to some of the same techniques, some of the same best practices used in exoplanet observing. Almost identically the same equipment, many cases the same filters. The only difference might be, for example, some of the observing techniques, some of the duration of observing, and the analysis. But we have, again, many resources and tools to help folks come up to speed on that. And that's really the last point, is that the AVSO offers a lot of those training opportunities and documentation and guides and software to help one come from astroimaging experience to exoplanet observing. So if any of you want to contact me, feel free, dentist@astrodentist.com. If you go to my website, astrodentist.com, you will find this guide that I referred to earlier, as well as a catalog of actual images, including all of the calibration frames, the darks, the biases, and flats that the guide uses as an example. So literally you could download those raw images and the calibration files, and the guide in its example walks through, as if you observe those yourself, walks through the total analysis using AstroImage. That makes it very easy for you to come up to speed on your own if you are not inclined to take one of our courses. I mentioned earlier that we have annual meetings. Just want to put a plug in for one coming up November 4th through the 7th in Tucson. And in fact, I will be doing a workshop on using AstroImage for exoplanet observing on the last day of that meeting. And finally, I'd like to make a special offer to all of you. As a local club member, what we're offering is a more than half rate discount on first year of membership in AVSO of a mere $40. You get access to all of the material, all of the manuals, all of the forums that members are eligible for. And if you are interested, just send an email to L Ward, which is Lindsay Ward. She's our marketing person at avso.org. Put club membership in the subject line. And in the body of the email, just put your name and the Minnesota Astronomy League club name. Again, this gives you sort of half rate membership for the first year. So with that, let me open it up for any questions.
Thank you, Dennis. Are there any questions here in the room? Yeah, and if you do, go to the mic. Are there any questions online, Matt?
Ron had posted something about recommending them by the web.
If somebody's asking a question, I can't quite hear.
You could repeat that.
Yeah, sorry.
Ron, did you posted a comment about James Webb doing a direct imaging of an exoplanet?
Ron Schmidt, are you online?
It was just released today. Direct imaging of an exoplanet. The link is in the chat.
Oh, so they've already done it.
First time today. Just
Yeah.
released. Talk about timely.
Yeah, yeah,
It's just a service we provide at the MAS.
yeah. You scheduled that observation for tonight, no doubt, right?
You know, it's a humble brag, but I'll take it.
Yeah, sure. Thank you. Yeah, by the way, there is a a chronograph on web. I don't know if that's what's posted on the link here, to try to do some direct imaging itself. It's kind of more of a pilot kind of test. I don't know if that's what the link is referring to, but yeah, web, in addition to characterize the atmosphere, it does have a chronograph on board.
So Dennis, you talked about no special equipment. I mean, I presume you're talking about a monochrome camera
Yeah,
and a certain pixel size, a certain image scale,
yeah.
focal
Yeah.
length.
Yeah. So, you know, I have, I'll just tell you my setup. I have a Osmondi G11 mount, so it's not, you know, kind of medium grade, you know, precision enough. I do auto guiding. I do on-axis guiding, not off-axis. I find that to be a lot more accurate. So I'm actually guiding on the target star, not on some star, you know, off field where there's still potential for image rotation. So a decent mount, you know, I'd say 11-inch or larger. However, we have observers who are using these EV scopes, 4.5-inch EV scopes, doing some exoplanet observing. You don't quite get with the resolution, but indeed, it is possible to even use a EV scope to help at least refine the period of confirmed exoplanets. So, you know, decent mount, you know, decent telescope, guiding definitely, a monochrome camera, ideally. Filters, I know most of you probably have RGB filters, but ideally getting at least one standard photometric filter, you know, like even just a V filter, if not a Johnson Cousins or SDSS filter. And really, that's about it. I mean, decent, you know, guiding software like PhD2, and that's about it. The observation times are longer. Typical duration of a transit might be 4 hours. So you're talking about an all-night observation where you might be collecting, you know, 500 or so images, depending upon the exposure time. And then doing the normal calibration, darks, biases, flats. And then finally, the differential photometry, with which AstroMJ helps you to do. And you're there. So it's probably the newest part would be the software, but all the normal best practice techniques would be the same. Obviously, you know, decent seeing. I mean, I don't have the greatest here in Annapolis. Typically, maybe 3 arc second seeing here would be good. Last night was exceptional. I had like 2.5 arc second seeing. Yeah, so.
That seeing sounds like a dream. That's not Minnesota skies, but
Yeah.
you know, but you know, I know there's one person in the club that does science. Do you know Russ Durkee?
No.
Okay. I think he's working toward doing some of this stuff. At least I haven't talked to him lately, but I know that he is he's doing other things, you know, so he's doing asteroids and things like that, color
Right.
curves and
Right.
stuff like that. So I have to believe that this isn't too far of a reach for him too. So
Right.
And there's one question in the room.
Well, apart from the variables, the eclipsing planets and stuff like that, do you have any other variable star discoveries that you've been a part of?
I've been mostly focusing on exoplanets. So I have not myself been involved in the variable star world. I did include very recently, in fact, the next daily build should include in AstroMJ the ability to use it for variable star observing. But I myself have mostly been focusing on exoplanets, not so much variable stars.
Terrific. Any other questions online or in the room here? Hey, Dennis, thank you very much for your time
Sure.
tonight. And hey, we'll keep watching. Maybe you're going to discover something big one day, and then we're going to say we know a famous person.
I Don't know. I think it's a team effort, so it'll be involved a lot of people. So,
Oh, I know that. I understand. But hey, congratulations. Thank you very much. Thanks for your
Thank you.
time.
Thank you. Good luck to y'all. And let me stop. I think I've stopped sharing, so it's all.
And everyone, that's the meeting for this month. And we'll see you on September 29th at 6:30. And we're gonna have cupcakes. Good night, everyone. Thank you for your time.
Good night.